Okay, everybody, welcome back to my SOL Grade 8 review videos. We have another multiple choice question, which you're going to find quite frequently on the SOL test. Not all of them are multiple choice, but many of them are. And this one's asking us to find the area of this irregular shaped polygon. So to begin, my advice, since it's an irregular shaped figure, my advice would be to break it up into pieces that you can manage. So I'm going to get yeah, we can use red. I'm going to go ahead and draw a line that sort of continues down through this piece right here to kind of break this rectangle apart from this rectangle. So now I have this rectangle here that is a 5 centimeter by 4 centimeter rectangle. And then I have this one here, which is an 8 centimeter by, well, I don't know how long this piece is. The whole thing is 12, but just this part here, how long is just this part here? Well, I think I got it. Since this much of it's 4, this much from here to here is 4, and if the whole thing measures 12, then this much here must be 8. Because this is 4 centimeters, therefore this is 4 centimeters. And if the entire thing is 12 centimeters, as listed right here, 4 centimeters and 8 centimeters together gives us 12 centimeters. So it's important to be able to determine your dimensions before we can actually solve this. Then, of course, we have a triangle that's at the top of this, which is 3 centimeters tall, or height, and then it has a base of 8 centimeters as well. So I've got everything labeled. I've broken it into pieces. Now what I'm going to do is try and find the area of these pieces and add them all together, and then I'll have the area of the entire irregular figure. So I have 3 different shapes on here, and I need the area formula for each one of them. Now you'll be provided the area formula using a formula sheet, but let me go ahead and list the area formula for each of these. First of all, the triangle's area formula is going to be 1/2 the length of the base times the length of the height. Then the area formula for the rectangle is going to be the length times the width. And then the area formula for the square is just side squared, or the same thing, length times width. So let's go ahead and do our triangle first. Our triangle is area equals 1/2 base times height. So 1/2. If this is our base, and this is our height, and we can use this as a height because it is a perpendicular measurement from this base to the opposite vertex. This is the opposite vertex from this base. And we have a perpendicular distance that measures from this base to this vertex. So I can use that as my height. When I multiply all of these things together, 8 times 3 is 24, times 1/2 or divided by 2, that's the same thing, comes out to be a total of 12. So then I have my rectangle, this piece right here. The area of that rectangle is 5 centimeters, the length, and the width 4 centimeters. And when I multiply those two together, that gives me a total of 20. I probably should list my units on here. Let's be accurate here. And then our last piece, this square that's right here, the area formula for a square was just one of the sides squared. Well, 8 is the length of one of the sides. So I'll turn that S into an 8. That's kind of convenient. 8 squared is not 8 times 2. It is 8 times 8. 8 times 8 is 64. Very common mistake that students make. Now there's something else that I forgot as I labeled my units here. It's not just centimeters, it's going to be centimeters squared. Since I'm finding the area of every single one of these figures, our units get squared. So now that I have the area of the triangle, and I have the area of the rectangle, it's supposed to be a rectangle, and I have the area of the square, I can just add these together to find the area of the entire object. So 12 plus 20 plus 64, that looks like, let's see, 106? No, 96. 96 centimeters. And again, if you're not sure, plug it into your calculator and you'll know for sure. So 96 centimeters squared is an answer, and look at that. C is 96 centimeters, or square centimeters. I feel confident that that is the correct answer. Now, there's lots of places to go wrong in this kind of question if you're not careful with what you're doing. For example, if you use 12 for the length of this little piece here instead of 8, or if you didn't know your formulas or know how to use your formulas, or if you didn't know you were supposed to add these totals together, this area amount plus this area amount plus this area amount. So there's lots of places students can go wrong in a question like this, but I have confidence in all of you that if you use your formulas and if you think about what's provided to you in this diagram, you'll be able to figure out enough information to help you find the area of all of these pieces and then glue them all back together to get a total area answer. All right, thanks for watching, everybody. Have a great day.